Welcome to our Occupational Health and Safety tutorial, Module 10 on Fire Safety. My name is Jonathan Scopes. With fire safety, we keep in our mind what we call the fire triangle. The fire triangle has three important sides. One side is heat, one side is oxygen, one side is fuel. So there are three sides, and we need to have all three of these in place to have a fire. So to have a fire, we need to have some fuel. We need to have something that can burn. To have a fire, we need to have some oxygen so the fuel can react with the oxygen chemically. And then we need to have some heat to start the fire. So oxygen, heat, fuel, all three for a fire. But the converse is also true. If I remove any one, I have stopped the fire. So if I remove the oxygen, the fire will go out. If I remove the heat, the fire will go out. If I remove the fuel, the fire will go out. So we need all three. Now think of yourself having a barbecue on a beach. To have a barbecue, you need some fuel, so you bring some charcoal. To have a barbecue, you need some heat, so you bring some matches or some other way to start the fire. And then the oxygen is provided by the air that we breathe. You need all three. Now suppose I get the fire going, my barbecue is going nicely, but I finish cooking, I want to put it out. There's three ways I can put it out. I can remove the fuel, so I can just let the fuel burn until it's gone and the fire goes out. Or I can remove the oxygen by covering the barbecue with sand. I smother the fire with sand, no oxygen with the fuel, the fire goes out. Or the barbecue's burning okay and I want to put it out, I pour water on it carefully. The water will remove the heat and I'll have fuel and oxygen but no heat. It's gone out. So the fire triangle, three things, and any one of them, removing any one of them, will stop the fire. We classify fire according to what is burning. So this looks complicated, but it's not as bad as it looks. A, B, C are basically solids, liquids, and gases. So Class A fire is a solid combustible material like wood or paper or textiles, cloth. Type B fires are flammable liquids like petrol, diesel or oil. Class C are flammable gases like natural gas or propane that we cook on, for example. Then we have three specialist ones. D is combustible metals, and to be honest, you're not likely to find combustible metals except in a specialist manufacturing facility. Class F is cooking oils or cooking fats, F for fats. And these you'll find in big hotel kitchens or in work camp kitchens. And these fires, which let's say it's for cooking samosas or cooking chips, the pan might be a metre by 20 or 30 centi deep of hot oil. So the oil is hot, it's going to burn well if it catches fire. So you need a special kind of piece of equipment to put it out, and we'll talk about that in the next slide. So Class F, and Class C, it's not really a class, but Class C means there's electricity with the fire. So we need to be careful about how we put that out. So A is solids, B is liquids, C is gases, D is metals, F is fats, and E is with electricity. So now to put out the fire, we need the correct type of fire extinguisher. The most common one and the cheapest one is water with the red. Now water is only suitable for burning solids, Class A fires. So it will put out fires on wood, on paper and fabrics, but it will not work for burning liquids, because if the liquid is burning and I pour water on it, the burning oil will float on the water, and wherever the water flows, the oil will flow with it and take the fire to another place. And the other thing we don't use water for is where there's electricity involved, because if there's electricity with the fire, I put water on it, the electricity can flow through the water, through the extinguisher, and then through me to the ground, giving me an electric shock, or the person who's fighting the fire. So water fire extinguishers are only for solids: water, paper, textiles. The next one we have is dry powder, that blue one. Blue is great. Dry powder is great. It works for Class A fires, solids, Class B fires, liquids, Class C fires, gases, and it's also suitable for electrical fires with electricity. But if the fire has, if it's electrical equipment, the dry powder will damage the electronics. Dry powder is really good, but it's really expensive. So we have another option, which is foam, which is the cream one. So foam is suitable for Class A fires and for Class B fires. Class A is solids and Class B is with liquids. So the foam is a mixture of water with a chemical. So because the foam has the chemical, it is suitable for liquid fires, and that's what its primary purpose is for. But we don't use foam for the fires with electricity because foam has water and the same problem, we could get an electric shock. Next one, the black one, is CO2, carbon dioxide. This is suitable for Class B fires for liquids, and it's suitable for electrical fires. So it's good for those two things, liquids and electrical fires, because the electricity will not travel through the CO2 gas. But it is not suitable for wood because it disperses too quickly. It's not suitable for metals. And the fifth one we look at is the yellow one, the wet chemical. And this is the specialist one for fat fires. So you'll find it in kitchens where they have big deep fat fryers. You'll have a special extinguisher for deep fat fryers. And it also works for wood, paper and Class A fires. So 5 types of extinguisher. Let's think about how the fire and heat spread. So the fire is burning next to the wall. Some of that heat from the fire will travel through the wall, and we call that process conduction. It conducts the heat through the wall, and because the fire is on one side, the other side also gets hot. If it gets hot enough and there's material against the wall, the material on the other side will catch fire because the heat has been conducted through the wall. So conduction. Convection is where the hot gases and the burning products rise up with the hot air that the fire has produced. That's called convection. So the hot air, the hot gases, and they can be very hot, they travel upwards with convection, and we'll see a picture of that later. Then we have radiation. So if I'm standing next to a fire, the fire's over there, but I stand here, I can feel the heat, and that's because heat energy from the fire has travelled through the air to me, and that's radiation. And radiation can start a fire at a distance. And the last type of heat transmission is direct burning. So if this thing is burning and it's next to this thing, there's the direct burning. The fire will just keep burning the next thing. So that's direct burning. So we have conduction through the wall, convection, hot gases rising, radiation, heat energy travelling through the air to us, and direct burning, where it's burning from one thing to the next. So conduction. So we have a piece of, let's say a piece of wall, and the amount of heat that comes through depends on whether the wall is thin or thick. So if it's thick, very little heat will travel all the way through, or it will take a very long time for the heat to travel through. But if it's thin, it'll come through quickly. It will also depend on what's the material of this wall made of. If it's metal, the heat will come through quickly because metal conducts heat well. That's why we have metal saucepans, for example. But if it's concrete, it will take a long time for the heat to come through, and it will resist the fire for a long time. So conduction, heat through something. Radiation. Radiation is the heat energy travelling through the air to the object, and the object will get hot on one side and it'll still be cold on the other until the heat has travelled through that object by conduction. But radiation is the heat travelling through the air, and the heat energy travelling through the air and reaching the material. Convection, so now in this picture the fire started on the ground floor, but the fire has caused lots of hot gas to be produced and smoke. So that hot gas and smoke has travelled along the basement ceiling, and then it's found a vertical shaft and it's travelled up the building, and when it's got to the top it can't get through the roof, so it's travelled across on the top floor. And because there's enough heat, that hot gas, just the gas itself, is hot enough to start the fire on the top floor. So now the firefighters have two fires to manage. The one on the basement where it started, and one on the top floor where it's travelled to by convection. Convection, the hot gas moving. Direct burning. In this picture we have some bushes and things burning, and then it's reached the pole, and the pole is now burning, and that's direct burning. The flames came to the pole, the pole caught fire, and the pole is burning because of direct contact with the fire, direct burning. Common causes of fire. Why do fires start usually? A common one is an electrical fault or electrical misuse. So you might see a socket overloaded. You might see a damaged cable. You might see an overloaded cable with too much electricity being pulled through it. The cable gets hot, the cable is on the carpet can start burning. So electricity. Accumulation of rubbish. So where we have rubbish, we're basically providing fuel for the fire to start in. Smoking is another cause of fire. It's the hot cigarettes getting thrown on the ground, or the hot matches being disposed of in an inappropriate way. Heaters. We don't have heaters particularly in Oman, but in the UK we have heaters, electrical heaters, which we plug into the wall sockets to heat the room. The heaters are fine by themselves, but if we put, say, clothes on them or too close so that we can dry the clothes, then the fire can get into the clothes and we've started the fire because of the heater. Equipment overheating. Another example would be the heaters. So I put the clothes over the heater gets too hot, the clothes get too hot, they catch on fire. Hazardous goods and materials, things like hairspray, any aerosol that's got butane or propane as a propellant. Those are hazardous materials, easily burned, and if they catch fire they can explode and send the burning material all over the place. Arson is a specialist word. It means the fire was started on purpose because someone had a bad motive. So if I had a bad motive against somebody, I might go to their house and start a fire on purpose. That would be arson. It's done deliberately. And then we may have work activities that are high risk for fires. So if we do welding, when we strike the arc, that's a hot arc, very hot arc. The sparks from the welding can travel to other materials. So if I did the welding on top of a carpet, the sparks might catch on the carpet and the carpet would burn. Or welding is one, grinding is another, produces a lot of sparks that can catch fire. Causes of death with fire. Well, interestingly enough, the most common cause of death is not the flames, it's the smoke and the gas carried by convection that most likely kills people, because they're breathing all this smoke and other contaminants that gets them and kills them first. Burns count for 27%, and then both together count for 20%. So that's 93% of deaths in fires are either the smoke or the burns or both together. So, how do we control fire spread? Well, first of all, we think at the design stage, what are we going to make this structure out of? We can choose to make it out of materials that resist fire well. So this building I'm standing in is made of concrete. Now, concrete resists fire well. The reinforcing steel bars, the bars in the concrete, they will get soft if there's a strong fire, and then the concrete structure will deflect or sag and it can collapse. But while the concrete is still around the steel bar, the bar is protected and the concrete structure will resist the fire. Then the things that we close the space with, like doors, need to be able to resist the fire. There's a picture of a fire door there. And we can buy fire doors that will resist the fire for 30 minutes or an hour, 2 hours, and even 4 hours. But the door has to be made correctly, and the door has to be fitted correctly. There must be no gaps round the door when the door is fitted, because otherwise the fire will come through the gaps. We can have compartments to confine the fire. So the building, if it was all open, the fire could spread across the whole floor quite quickly. So what we do is we divide the floor with walls. Walls, what we call fire compartment walls, and fire doors. So if there's a fire in this room, it gets stuck, it gets contained in the one room, and we can put the fire out. It can't spread to the rest of the building. So fire compartments. And if we have a big area, like a shop, a big shopping mall, like a big supermarket, then you might have sprinklers, and sprinklers are outlets for firefighting water. So the outlet, the sprinkler head, has what we call a fusible link. When it gets hot enough, that link will break and the water will be pumped out by the fire pumps and from the fire tank, and the water will come and put out the fire. And those sprinklers will put a lot of water out. In their area, they might produce 12 or 13 millimetres of water across the whole area. So, as we design the building, we think about how to avoid open shafts. So the shaft might be for a lift. Well, now think about the lift shafts that you've seen. They've got a lift door, but they've also got another door round the stairwell, so that there's 2 doors between a fire potentially and the lift, the vertical shaft of the lift. But you can have other shafts in a building, maybe where the stairs are. Open stairs are a way for the hot gases to travel by convection to another place. And another source of vertical shafts are where you have pipes travelling up through the building. You've got holes in the building, maybe in a cupboard, for the pipes to travel up the building. And those vertical shafts are another possible route for the hot gases to be carried by convection to start a fire somewhere else. False ceilings. The ceiling, if we don't like the concrete slab, we might put a false ceiling, the ceiling tiles underneath, to hide ductwork, for example. So the false ceiling provides a place for the fire to travel. So false ceilings we need to control by boxing them in with fire compartment walls. Air gaps behind walls are another place for convection to occur. So where we have holes in the wall, maybe for an AC duct or for a pipe to go through, the pipe goes through there, we seal the gap round the hole, we seal it with fire resistant material so that the hot gases cannot travel through it and the fire is contained. And then the doors themselves must be properly fitted. So the doors will have closers, so they close automatically. So the doors, if we leave the door open, it closes itself to stop a fire. Or the door might have what we call an intumescent strip round it. The intumescent strip is a material that if it gets hot expands and closes the gap, the small gap round the door, to stop the fire spreading. So that's safety by design. Fire detection. So we have different types of detectors: smoke detectors, flame detectors, and heat detectors. Smoke detectors we split into 2. They can either detect the smoke with ionizing or with optical means. So ionizing is the most common. You see a little smoke detector on the ceiling. There's a source of ionizing radiation and a small detector. And if the detector detects a constant stream of ionizing radiation, it does nothing. But if some smoke gets in the way, then the ionizing radiation can't get through. The detector detects there's less radiation, so it sounds the alarm. The optical one works in a similar way. These ones can be big distances apart under the roof of a large warehouse, for example, and they can be 30 or 50 meters apart. So you have the light source and the detector, and the detector is detecting the light source, and as long as there's no flame and no smoke, it's fine. As soon as the smoke gets in the way, the detector says, I'm not getting so much light, it sounds the alarm. The problem with both these types of detectors are smoke will detect and sound the alarm, but also dust. So if we have a dusty environment, we'll get what we call false alarms. It's the dust that's caused the alarm, the detector to sound, and not the fire. Flame detectors look for a particular type of light. So they might detect the red infrared light, or they might detect the blue ultraviolet light, depending on the heat of the fire. And you can set those according to the type of fire that you expect might happen in your building. Then heat detectors need the actual flame, actual heat to detect. So usually they're two bits of metal joined together, that you set it so one metal expands more than the other. So when they get hot, this one expands, causes the two joined metals to bend, make the electrical contact that sounds the alarm. So three types of heat detection: smoke, flame, and heat detectors. Means of escape. So if the fire starts, we want to get out in a controlled way, smoothly and easily. To do that, we need to have a route that is clear of obstructions. It should be well lit. Even if the main power has gone off because of the fire, the emergency lighting should be giving us a clear enough route to get out. We want the emergency route to be well signposted. So you're in, let's say, a hotel that you're not used to. You see the green sign and you follow the green signs and get out the building safely. It needs to be wide enough. So there needs to be space. If there's only 5 people to get out, it can be quite narrow. If you have 50 people, it needs to be wide enough for a group of people to travel smoothly together and quickly out of the building. The fire escape route does not want to be too long, otherwise we'll be in the burning building for a long time while we travel this long distance. So you want to have fire escape routes that are reasonably short so people can get out quickly. The doors should open in the direction that I'm running. So if I'm running this way, the doors should open in front of me so I can carry on moving. If the doors are like this and they have to come towards me, I may get panicked, or the person behind me may push me, and then we'll not get through the doors and we'll be stuck. So doors should open in the direction of travel. And then when we get to the end of this escape route, we should be in a safe place outside the building and be able to escape. What we don't want is what's in the bottom picture, where the fire escape place has become a storage area, and that is not suitable for escaping. Right, emergency lighting. I mentioned emergency lighting, but we need to have lighting so that we can see, if we're underground, how to get out. If there are no windows, there's enough light from the overhead lights, the emergency lights, to find our way out. If the stairs don't have windows, we need the emergency lights on the stairs. Maybe corridors have no windows. We need lighting so we can get out. And then also areas outside, if there's a possibility of people working at night, there should be emergency lighting so if there's a fire, they can still find their way to a safe place, even when it's dark outside. And then assembly points. An assembly point is a safe place for us to go after we've evacuated the building, where we can check has everybody got out? We can count, have you seen that person? Yes, he's here, good. Or we can say to the fire emergency services, we think there's still somebody in the building. And that's very important information for the firefighters. So the fire assembly point needs to be close to the building, so we don't have to go too far, but it needs to be away from the building so that we're not affected by the fire and we're not in the way of the firefighters while they fight the fire. There needs to be enough space. So if it's a big building with many stories and lots of people, the assembly point might have to be even 400 metres away, because that's where there's a safe place. And then shelter is things like shade in Oman to keep the sun off, and it's shade in the UK to keep the rain off. So those are assembly points. And this is just to say thank you for listening, and you can follow us on Instagram, Twitter, LinkedIn and Facebook.